In this video, we are going to discuss about the voltage controlled oscillator. So after completion of this voltage controlled oscillator, the students will be able to explore the use of high gain inverting CMOS amplifier, and also they can use it in the voltage dependent resistor. So first, what is voltage controlled oscillator? It is nothing but it is an electronic oscillator whose output frequency is proportional to its input voltage. So this oscillator produces a periodic AC signal, and this oscillation frequency is mainly determined by the voltage. And the voltage controlled oscillator, here this frequency can be controlled or varied by the DC input voltage. So this type of circuit can be called as voltage to frequency converter. And the output waveform from this voltage to voltage control oscillator, maybe it can be a sine, square, or other wave shape depending on the circuit design. So the main principle of this voltage control oscillator is it is an oscillator with an output signal whose output can be varied over a range which is controlled by the input DC voltage, and also it is an oscillator whose output frequency is directly related to the voltage as its input. So this frequency can vary from few hertz to hundreds, and the timing capacitor is linearly charged and discharged by the constant current. This current can be controlled depending upon the voltage it is supplied by changing the timing resistors. So this modulating voltage can be increased or decreased depending on the limit of the voltage, and here this is mainly used for whether in the discrete, modular, or monolithic form. This fills the needs for voltage based frequency control, and also it is required in number of applications. So they can be used in function generators, PLLs, frequency synthesizers, clock generators, and also in the analog music synthesizers also. Why we are calling this as voltage control oscillator means it is an electronic oscillator whose output frequency is proportional to the input voltage. So when this oscillator produces a periodic signal, and in voltage control oscillator, the oscillation frequency can be determined by the voltage, and this voltage across the capacitor is applied to the inverting input terminal, and the output voltage is also designed here. So this can be varied between a particular value, and when it exceeds it charges, and if it is if it exceeds it discharges, and if it is not having the voltage it will be charging it. So based on the timing requirements, it will produce the charging and discharging times. And next is how we are using the voltage control means passive compensation. That is, we are using this as in the circuit breakers or switches are used for connecting or disconnect the compensation. So for active compensation, we are capable of continuously varying the voltage control, and mainly this can be used in the active compensator. The main frequency ranges between 2.4 to 12.12 gigahertz. So this can be a phase of output things. Mainly it can be used for the charging as well as discharging. And this voltage controlled oscillator can be classified based on the tuning methods and the circuit elements. So that can be included in the linear tuning, exponential tuning, octave tuning, and the switched capacitor. And also they can be designed depending on the some extent of phase loop, locked loop, in which they can be embedded in it. So frequency should be in the form of 200 megahertz, and also this gives the triangular voltage waveform across the circuit, and it is capable at the pin 4. So this can be shown in the inverter A3, which is basically used for charging as well as discharging. Thank you.